Alrighty, my friends, let's go ahead and talk about some power series and convergence. So a power function is simply something like x to some power, like x to the fourth. So it's basically a variable raised to some sort of power. Now, to make that into a series, we add them up, because that's what a series is. So it looks kind of like a polynomial. It's a little bit of a way you could think about it. Alrighty, now we're going to see how we can use our tangent lines in a different way. So let's see. How do you write a tangent line for f through the point 0, f of 0? So the tangent line is just take the point, f of 0, add the slope, f prime of 0, and then x minus 0. And then how do you write a tangent line for f of x at the point c, f of c? So that's f of c, same idea, plus f prime of c, x minus c. How can we make a tangent line a better approximation? Well, I have some ideas. So I'm not going to share them though, but I'm going to give you a hint. When we think back to like Riemann sum ideas, to make a Riemann sum a better approximation, Riemann sum was making those rectangles, remember? To make that a better approximation, what did we do? We added more and more rectangles. When we think back to Euler's method, to make that, Euler's method was a repeated tangent line idea. To make that a better approximation, if we do more tangent lines, then that would have given us a better approximation. So that might give you an idea of what we need to kind of modify here. Ooh, a Taylor polynomial and a Maclaurin polynomial. Okay, so let's look at this. This is saying the kth derivative, and then this is x minus the center to the k. Okay, so if I relate it to what we just did, let's write down. So in the beginning, that's just going to be f of whatever x naught is. And then, because that's like the zeroth derivative, and 0 factorial is 1, and then x minus x naught to the 0 is 1. And then if I do the first derivative, so that's going to be f prime, 1 factorial is 1, x naught I should put there, and then x minus x naught to the first. That's a tangent line. That right there is basically what I wrote, except instead of c, I wrote x naught. Well, the next term would be the second derivative over 2 factorial, and then x minus x naught squared. Then the next term would be the third derivative, x minus x naught cubed, with 3 factorial. So basically we just keep adding derivative pieces. So that adds some specificity. So instead of having a tangent line, it makes it into like a parabola if I have just that piece, or a cubic function if I have that piece. And we can look at some examples where as we add more and more terms, it gets closer and closer to what the curve is. Now look at the Maclaurin. What's the only difference? The only difference is our center is 0. So Maclaurin is just a Taylor polynomial that has a center of 0. Now, in our calculus class here, we don't care that much about the polynomial nature of things. We care about the infinite series. So that's what we're going to make use of here. So to make them infinite, we just keep going. So let's pick a function we love and build one. I'm going to pick the sine. So let's suppose we have sine x. And let's center, so sine x centered at 0. So that sine x at 0 is 0. Derivative is cosine x. Let me erase that. There we go. And that's cosine of 0 is 1. Derivative of that is the sine, negative sine of x, and that's 0. Derivative of that's negative cosine of x, and that's negative 1. Derivative of that's the sine of x, and that's 0. Derivative, that's the cosine. Wait a minute. Not cool. Cosine of that's a repeating pattern. So let's go ahead and write down what this is. So f of 0 plus f prime x minus 0, that's a 1, over 1 factorial, plus f double prime x minus 0 squared over 2 factorial, plus f triple prime x minus 0 cubed over 3 factorial, plus f quadruple prime x minus 0 to the 4th over 4 factorial, plus f, the fifth derivative. I forgot how to talk there. All right, I think I see a pattern. Do you see a pattern? So here's your pattern. You have x, and then you have minus x cubed over 3 factorial, plus x to the 5th over 5 factorial. It'll be minus x to the 7th over 7 factorial, etc. So I'm going to call that x to the, okay, so it's an odd number. So if I multiply any number by 2, that's an even number. And then if I subtract 1, that's an odd number. So 2n minus 1 over 2n minus 1 factorial. You could also write it as plus 1, because 2n plus 1 and 2 is the same idea as 2n minus 1. It's just starting at a different, maybe I'll do plus 1. So I'll do plus 1 because then I can pretend n is starting at 0. So this is the 0th term, this is the first term, this is the second term, etc. So hopefully that makes some sense to you in your brain just a little bit, because that was the first time we did it. So here's my challenge to you. Use this idea and do this idea try for cosine x. Also try for e to the x. So you take derivatives, you plug in 0, because these are Maclaurin or Taylor series centered at 0, and then build it using that kind of formula or those steps from the previous page. Good luck, my friends.